Hi everybody, my name is Marius and today I'll be doing video 3 on the series of ABCs of ADVPN. If you haven't seen video 1 and video 2 and you don't quite understand how ADVPN fits together, I highly suggest that maybe you go back and actually have a look at those two videos as I try and explain the basics of the ADVPN concept there. If you remember in video 2, what we pretty much did is we connected two spokes to a hub with one VM server, and we looked at the flow of traffic within those constraints of that actual small network. The idea was never to really build up the scalability at that point. It was never to have the actual backup or redundancy. The big thing about that was just understanding the traffic flows. So what I'm doing today is I'm starting to look a little bit into the scalability, right? And more specifically scalability, not necessarily with just multiple hubs, but more around the actual use of groups. And as I go into this actual presentation, you'll see as I move through it that there are certain things I'm going to really touch on from a routing point of view, for instance, and then also from a scalability point of view when it comes down to the actual VM server and the actual hubs. So I'm going to actually split this into two little segments, right, as we move forward. Good. So effectively what I want to do is, if we look at the next slide, is you can see that I've changed slightly from video 2, just a couple of IP addresses and so forth, and I've also introduced something called ISP2, spoke 3 and hub 3 at the moment. Right, that's quite important that you just notice that. And also, like I said, if you did look at video 1 and 2, I've changed the IP addressing just slightly. The reason I did that is simply because I just wanted to make sure that we keep things logical. Alright, and you'll see as I configure going forward that what I try to do now is to keep it as logical as possible, so we don't sit there figuring out what IP address to use. So one of the things I have changed is the actual 192 addresses, right, from video 2. So I'm actually using a 21 and a 22 now, and if I remember correctly, I used a 36 and 37 if I remember correctly. Okay, nothing serious, but for now this is group 2, so I just call this 21 and 22. And this is, of course, group 3, you'll see just now, and I made this 31, yep, as we move forward. So from that perspective, so you can just start to get an idea of where we're going with this. ISP is still exactly the same. I didn't change the WAN interfaces. I also did not introduce new protocols or anything like that. The one thing I have done is I actually flattened this network slightly, because previously VM 1 was directly connected to ISP1. And also hub 1 was directly connected to ISP1. I do have a limitation of 4 interfaces on my infrastructure, so what I had to do was introduce a second ISP, which is not a bad thing. Alright, so what I did is I just created one flat network over here and get them all to connected. So this is just a connectivity issue that I had. That's the reason why I changed some IP addressing here. Very important for you though is that your new VM server IP address is not the 202.115 that we used to have. It's now changed. I think it was 5.1. Now it is actually 1.101. Alright, what you'll see is my ISPs actually uses 200s, that's 201, 202, just to keep it logical. And at some point you'll see this is 202.115.11, which is hub 1. Alright, I'm going to introduce a hub 2 at a future video, which pretty much will become the 1.2. Okay, 1.3 is hub 3, and 1.4 will turn out to be basically your hub 4 in future videos. Once again, I'll also introduce a new VM server as well going forward, and that VM server will of course then be 102. So you can see where I'm trying to get the logic behind these configurations. Okay, looking at the next slide, BGP, I've also changed slightly. BGP now is 101 in group 1, 102 is group 2, and 103 is group 3. Just by very quickly looking at this, I'm pretty sure you can see right now that we still have a hub and spoke environment. So hub and spoke meaning that as I look into the actual configurations, how do I know that, by the way? Okay, this is hub and spoke simply because the actual hub and spokes are not in the same AS. And that then creates a hub and spoke environment that we basically use as a default. Right, so this is hub and spoke at the moment, and I've introduced some, basically multiple ASs here. So as you can see, if I hit the next slide, what I've done is I've created group 1, group 2 and group 3. Yeah, right now we don't really need that, do we? Because we only have 3 spokes. But in real life, you know, there might be thousands of spokes in here, and that's where I'm going to really work on today. Is really helping you understand, right, why you would use groups and where the groups actually make a big difference. So what we're going to have initially is we're going to actually have a hub and spoke environment where this interface, you know, whenever somebody pings from a 21 to a 22, the traffic will flow right now into the hub and down to the spoke 2. So there will be no dynamic tunnel set up. This is hub and spoke. Okay, what I'm going to do then is basically, I'm not going to confuse things too much. I'm going to actually at some point get here, and this used to be the old design as well, and you looked at domains, it was always hub and spoke. And this is one of the issues that we have today in an automated DVPN solution. Okay, one of the things we need to know is there's got to be some type of address management system. Right, IP address management system. This guy makes a decision, the spoke. He needs to go from himself, let's say at some point, and he's got to go to another device. Okay, so there's one way he can know this. Of course, there's a public infrastructure. He will learn these routes through either a routing protocol or through some type of static route that you've entered in there. There's a scalability issue in all of that. Right, we know with OSPF, if you grow these groups too big, what happens is that they start to have to manipulate the backplane the whole time. They're going to sit there whenever there's a change on this spoke. Every router in that group would have to do a recalculation on the LSA database. Okay, so that's what I'll talk about at the moment from a scalability point of view in the routing protocol. But also this guy needs to know a lot to make routing decisions if he wants to go spoke to spoke. He needs to know about this IP address. More importantly, he needs to know that this IP address is bound to a public interface, right? Public IP. And he's got to either know this information or he's got to know who to ask. And that's where the VAM server comes into play, right? If you have a VAM. This VAM server, remember, if you remember from video 2, remembers this public information. It also remembers the tunnel interface, and it binds all of this together with an actual network. Up to now, this was not that important because I actually had the routing protocol take care of that for me. Once you start to create multiple groups, this becomes a bit of a challenge. All right, there's one of 2 ways we can handle this, and this is what most vendors today do. They actually, if they extend into scalability, they create a hub and spoke environment. So what I see a lot is they'll have a full mesh over here, full mesh environment, and they'll have a full mesh environment over here, and what they'll do is they'll have a hub and spoke between the actual areas, logical areas. Okay, so traffic will always then flow across. One of the advantages of the new ADVPN from HP is that you can now actually set up a spoke-to-spoke session, right? Which means full mesh, doesn't have to be hub and spoke. You can set up a full mesh environment between areas. What's cool about this, if you think about areas at the moment, is that he needs to know a lot of information about all his devices in this infrastructure. Yep. This guy will need a lot of information about all this device and infrastructure. Now, if you want to put a large infrastructure down over here, this router capacity needs to increase. It's going to be high end, but typically we actually use low end routers here. So this is what sometimes creates a bit of a challenge, because if you have a low end router, you can't put big routing tables on there and you can't do a lot of calculations, and that will then determine the size of your group and sometimes the protocol as well. So what you want to do is you want to logically segment, right, areas and groups like this, and that's what they did very, very successfully in OSPF. Okay, this would be area 1, and this would be area 2 and area 3, and this router would know a lot about this infrastructure, and he would basically rely on his ASBR or ABR, depending on if he's connected to an external network or not. Okay, so the area border router, he would rely on him to make some decisions for him. You're going to see the same thing happen today. Okay, as the traffic flows through this network. Let me just clear this off quickly, and then I can do that again. Okay, so as the traffic starts to flow through the network, if he wants to talk, this guy wants to talk to that guy, there's got to be some type of routing in place. He's got to know about this network somehow, by the way. Okay, so you'll see initially that he says to get to all other networks, right, what I have to do is go via my tunnel interface over there, and you'll fire the first packet up. At some point you're going to have a VAM server sitting over here, right, and the VAM server at some point, you'll see this, is going to either tell this guy or not to use full mesh or not. use full mesh. Okay, the default behavior is not to do full mesh, it's hub and spoke. But I'll show you basically through configuration how you can do this into a full mesh environment. Okay, so as the first packet hits this hub, the hub will forward the packet down, right, and the traffic will go through. At the same time, what this hub will do is the hub will send down a packet, say to him, redirect. Okay, I want it to redirect. So this guy is going to say, well, redirect to what? He's going to say redirect to 10.1.3.3. Okay, so now I know something. I need to send, basically not send to 10.1.2.1, I have to send to 10.1.3.3, which is his interface. What he does then, very next step, is to literally go there to the VM server and says, well, I'm going to 192.168.31.x0, yeah. And basically I know that the tunnel interface I want to use is 10.1.3.3. Do you have the public IP for me, please? Sure. The public IP at this stage would be, if I remember correctly, was a 202.115.13.1. Right, and that's the important IP that I need. Okay, VM server will give this information back to him, and you'll see him set up a tunnel directly to spoke 3. So the very next packet basically flies across. He's redirected the traffic, told him to redirect. He found out from the VM server, hey, by the way, what should I do about that information that I have? VM server gave him the public IP information that he needs. He then sets up an actual tunnel interface, or uses his tunnel interface there to connect to the other tunnel interface, because he has a public IP address. That's possible. Okay, so in routing, you'll see that we're going to be running BGP, right? Very important. I can do this as well in BGP. I don't need all of this to happen. What I can do is I can just peer from spoke 1 to spoke 3. I can just create a peer entry. But this starts to basically create a bit of a challenge, because we do say it's automated ADVPN. Yeah, okay, so automated. I want to automate this. I don't want to have a static entry for every single thing. So you'll see with the configuration that for BGP, this is the advantage of the BGP. I point to one neighbor only. However, at some point, I'm going to directly route to him. So if we don't use BGP, because BGP will have an entry to get to this route, remember in the routing table, but via the actual neighbor statement. So what the router now does, it will create a static entry, static IP, to get to 192.168.31.1, let's say, go via the 10.1.3.3 with a cost of 8. Okay. And that's what I want to show you today in configuration. This all sounds really complicated. So it's not, believe me. Okay, but you have to get it right. So what we have to do on the VM server is two things. The first thing you have to do is create an access control list. Well, this is not really true. You have an option where you can actually say all traffic is full mesh. I would be very careful about that, because it means that literally all traffic is full mesh. Okay, so I would create an access control list entry, and I would say, well, anything coming from a source of 21, when I say 21, I mean this 21, yeah, going to a destination of 31, I want that to be full mesh. And then vice versa, anything coming from a source of 31 going to a destination of 21, right, from 31 to 21, I want it to be full mesh. That's my access list. Okay, I think that's already created in the router. I don't want to type all of that out. I'll just show you that. Okay, then you actually want to go to your VM server, not the actual hubs. You go to one device, the VM server, and you tell the VM server, right, I've got a shortcut. That's the keyword. Shortcut, right. And for interesting traffic. And you're going to point to the access control list 3000. You're going to point to this. What this guy will do now is, the very next step, as soon as you hit enter. Okay, by the way, why do you create a shortcut? That's created in the hub groups, hub group 3 and hub group 2. Okay, that's important. So you realize that you'll see in configurations. Once you create that and you hit enter, the VM server actually communicates to this box and says to him, hey, by the way, you've now got shortcut information. Shortcut, if you come from a source of 21 going to 31, right, I want you to send a redirect packet down to him. Okay, very important. So that's basically how the system works, and then vice versa, I'll do the same thing over here. He's going to send him a shortcut as well, and that's what I'll show you in configuration. Okay, so once again, logic is always the important thing. The configuration just literally just 4 or 5 lines of code and you're done. Okay, so let's get right into it. Let me just bring up all my devices. That would be spoke 3. This is spoke 2. I believe that's spoke 1. And that would be hub 3. This would be my VM server. And this would be my hub 2. Okay, so I'm going to just show some routing table information to you. Okay, display IP routing table to get to 192.168.31.1. 10.121 is my default gateway of the actual hub 1. Let me prove that to you. Display interface brief. Okay, tunnel 2 10.121, that's group 2 that we're working in. So his default gateway is the hub for 192.168.31.0. This is spoke 3. Display IP routing information, right, for 192.168.21.1. That is 3.1. Display interface brief. Sorry about that. Display interface brief. And it's going to check that. And that's 10.131. So at the moment I've got a hub and spoke environment. But you're going to say to me, oh, but you don't have a session yet. Okay, that's fine. Let's just quickly do this. Display ADVPN session. There's only one session. It's spoke to hub. Yeah. So now I start with a ping -a coming from 192.168.31.1 going to 192.168.21.1. Ping works well. Okay. And let's do a ADVPN session. At the moment, it's still only one session. That's hub and spoke, right? And if I do the display IP routing information, right, 192.168.21.1, it's still 3.1. Okay, so everything has stayed exactly the same. And the reason for that is very simple. If you do a display VM client shortcut and interesting traffic, it says right now there's nothing really interesting about this. There's no access control list rules. Okay, and this is where I want you to see what's going to happen. I'm going to do a terminal debug and terminal monitor, and I'm going to say debug VM client all. Okay, the same thing would happen over here. Well, we can just run there. Terminal debug, terminal monitor, and debug VM client all. Okay, so let's look at this boy here. Display access control list all right now. Display access control list all. Sorry about that. Okay, if you look at this, I've got a rule 10. That's access control list 3000. Rule 10 says permit coming from a source of 192.168.21. That's this guy here. Going to 31, which is this guy over here. That's just a hello packet, by the way. Okay, and I'm also vice versa, coming from 31 going to 21. I love this because I've got control here. Right, and then I say display current configuration pipe beginning with VM server. Okay, there's my VM server configuration at the moment. As you can see, I've got the standard configuration. I've got hub group 1, which I need. Right, and I need tunnel interfaces for it. I've got hub group 2, which is a hub private address 10.121, and of course a spoke, a range, and I've got hub group 3, which is 10.131. That's my hub, and my range of 10.133 to 10.13100, which is these devices connecting up. Yep, that's these two. So you'll see a slightly different configuration than before. Before we only had hub group 2 because we only had one hub and a couple of spokes. Right, I didn't need the hub to hub communication. As soon as I introduce the second hub, I need the hub to hub communication, and that's got to be one common group. Right, that's hub group 1. And that you'll see is slightly different to what we did before. From a BGP point of view, if you did this, display current configuration, but beginning with BGP. Okay, what's important is that at this point, this guy only has one peer, 10.1.2.1, which is this hub over there. He's got nothing else. He doesn't know about these routers over there. So from a scalability point of view, it's quite easy to set this up. Right, everybody inside this group here. So even if you look at this board here, the spoke 2, display current configuration, right, beginning with BGP. You see, he also just points to 10.1.2.1. It's quite easy to set this up. All right, it's not complicated. From his point of view, display current configuration, right, beginning with BGP. You see it has changed slightly in this case because what I have now is cancel. Sorry, I don't want to close that down. I want to move this up. Okay, so he now has a new peer. He's got a peer for 10.1.1.3 as well, which is in the same AS. That's new. Okay, he then says, I've got networks there. You've got to enable the 10.1 network, otherwise they don't know how to route to each other. It's still routing. Routing still applies. Okay, so I've got a peer 10.1.1.3 enable, and that's it. By the way, I was messing around with allow AS loop. You don't really need that. I was just messing around with that to see something. Okay, so you basically enable this new peer. And that is important for BGP, and that's the only thing that's changed in the meantime. And vice versa, of course, on Hub 3 as well. It's got the same setups as well. Okay, so let's go to this. I want to apply that access control list, all right, range. I want to apply that in some form or fashion. So what I do is I do a VM server, ADVPN domain. My domain is the name. I'll get it right at some point, all right. And we now have my domain, and remember this happens in the hub group 2, because you want to have control between the hub groups. Then I'm going to say a shortcut, interesting traffic, and you'll see I've got two options there, access control list or all. Don't use all. I promise you, if you say all, everything is full mesh. Okay, so if you want control here, it's access control list, and what's the name of the access control list? All the number, which was 3000. Boom, immediately as I hit enter, this guy started working. What you'll see now is if I do a display VM, alright, client, shortcut, interesting traffic, I now have the information about the access list in here. Okay, as you can see, I could have actually just done it once, but I decided to put it in twice just to make sure. Good, so at this point, display VM client, yeah, shortcut and interesting traffic. Still got nothing. So if you were to leave it like that right now, and let's do it that way, because now I've only applied it in hub group 2. Yeah. So let's start the ping from this side. So hub 2 will give me a redirect. Okay, so that should happen now. So if I do a ping -a coming from a source of 192.168.21.1, going to a destination of 192.168. Before we do this, before we do the ping, let's just verify some stuff. Display ADVPN session. I only have one session for now, right? Then I have the spoke to spoke. Display IP routing table for 192.168.31.1. That's 2.1, which is my default gateway of the hub. And now I do a ping -a coming from 192.168.21.1 going to 192.168.31.1. You still with me now? Okay, so I'm pinging from spoke 1 to spoke 3. Okay, now do a display ADVPN. That would help if I do a display ADVPN session. This time I have two sessions. I've got a spoke to spoke as well. Okay, this guy would also have a spoke to spoke. He's got to have it. Display ADVPN session. He's got to have a spoke to spoke. Okay, but I'm going to quickly show you the difference between the two now. So if you do here display IP routing table to get 192.168.31.1, right, suddenly it's changed to his default gateway. Let me show you. Display interface brief. His IP address 10.1.1.3. So effectively what I'm doing now is I've actually spoken to the VM server. I got that information of his public interface, and I've actually set up a session to him directly. But this is where it becomes interesting. Display IP interface. Sorry, let's do it this way. IP routing table, right, to get to 192.168.21.1, 2.3, right. So the session is effectively set up between the two. But if you do a display command, what you'll see at the moment is that this guy is not showing the information. Okay, so what I like to do is, from a control point of view, this is setting up the session one way. Okay, so if I do this, reset ADVPN session, display ADVPN session, it's gone. And by the way, if I did this now again, display IP routing table 192.168.31.1, it will then point to my default gateway again, which is my, not default gateway, but my hub. Right, and I do this, display ADVPN session, it's done again. If I do it this way, ping -a coming from 192.168.31.1 going to 192.21.1. Okay, that's a success story there. I've got session spoke to spoke again, and display IP routing table 192.168.21.1. Okay, 10.123. You can see it set up. Okay, so all you have to do is at some point get a redirect and send it through. To keep it easy, what I like to do here is hub group 3 and apply the access list as well. Okay, it just makes it from a troubleshooting point of view. You can now see this. Display VM client shortcut interesting traffic applied. Okay, it's just very quickly for you just to see how that works. Alright, brilliant. Okay, so that was easy enough, not too difficult at all. And one more thing I wanted to show you was that you've introduced a static route at this point. Okay, so there's a static route that you could use. So if you did display IP routing table BGP IPv4, BGP, it should be IPv4, yeah, table, there it is. Okay, good. Sorry, I wanted to get in there. You'll see that I've got a 192.168.1 address. I've got a 192.168.22. Why is 22 in there? Well, simply 22 is not redirected. So let's confirm that. Ping -a coming from 192.168.31.1 going to 192.168.22.1. Okay, did it set up a session or not? No. Why? It's not interesting traffic to me. Okay, that's not part of the shortcut. So if I did this and I did a display IP routing table to get to 192.168.21.1, it'll point to the actual hub spoke, yeah, sorry, to the spoke one. And if I do this for, that's what I was thinking of, 22, it'll point to my hub. Okay, and that's how you can control spoke-to-spoke traffic and full mesh traffic and so forth. Alright, so you really have control in this point, you know, where you can actually control the different types of traffic. And that's where the areas come in. The great thing about this is you don't have to set up a bunch of BGP peers and so forth, right, to get them all to peer together, to get a full mesh environment. You can now start to segment groups of routers, right, and have one peer pointing to the hub. Set up your groups with interesting traffic and shortcuts. Once you've done that, it will actually introduce a static route between the actual devices, and this is the magic of the actual area. So I can really, from a routing point of view, keep this very small, right, with the peer statements and so forth, and I can really increase the actual devices themselves. Okay, so that's the end of the video. I hope you found this useful at some point. All right, and we look forward to seeing future videos. Thank you very much. Bye bye.